Modern power system. The modern power system of today is a complex interconnected network as shown in the figure. A power system can be subdivided into four major parts. First is generation, second transmission and subtransmission, third distribution, and fourth loads.
Generation. Generators. One of the essential components of power systems is the three-phase AC generator known as synchronous generator or alternator. Synchronous generators have two synchronously rotating fields. One field is produced by the rotor driven at synchronous speed and excited by DC current. The other field is produced in the stator windings by the three-phase armature currents. The DC current for the rotor windings is provided by excitation systems. In the older units, the exciters are DC generators mounted on the same shaft, providing excitation through slip ring.
So today's system use AC generators with rotating rectifiers, known as brushless excitation systems. The generator excitation system maintains generator voltage and control the reactive power flow. Because they lack the commutator, the AC generators can generate high power at high voltage. Typically, 30 kilovolts. In a power plant, the size of generators can vary from 50 megawatts to 1,500 megawatts.
Transformers. Another major component of a power system is the transformer. It transfers power with very high efficiency from one level of voltage to another level. The power transferred to the secondary is almost the same as the primary.
The purpose of an overhead transmission network is to transfer electric energy from generating units at various locations to the distribution system, which ultimately supplies the load. Transmission lines also interconnect neighboring utilities, which permits not only economic dispatch of power within regions during normal conditions, but also the transfer of power between regions during emergencies.
High voltage transmission lines are terminated in substations, which are called high voltage substations, receiving substations, or primary substations. The function of some substations is switching circuits in and out of service. They are referred to as switching stations. At the primary substations, the voltage is stepped down to a value more suitable for the next part of the journey toward the load. Very large industrial customers may be served from the transmission system. The portion of the transmission system that connects the high voltage substations through step-down transformer to the distribution substations are called the subtransmission network. There is no clear delineation between transmission and subtransmission voltage levels.
Distribution. The distribution system is that part which connects the distribution substations to the consumer service entrance equipment. The primary distribution lines are usually in the range of 4 to 34.5 kilovolts and supply the load in a well-defined geographical area. Some small industrial customers are served directly by the primary feeders. Distribution systems are both overhead and underground. The growth of underground distribution has been extremely rapid, and as much as 70% of new residential construction is served underground.
The secondary distribution network reduces the voltage for utilization by commercial and residential consumers. Lines and cables not exceeding a few hundred feet in length then deliver power to the individual consumers. The secondary distribution serves most of the customers at level of 240 to 120 volts, single phase, 3-wire, 208 line-to-line to 120 volts, 3-phase, 4-wire, or 480 line-to-line to 277 volts, 3-phase, 4-wire.
Loads. Loads of power systems are divided into industrial, commercial, and residential. Very large industrial loads may be served from the transmission system. Large industrial loads are served directly from the subtransmission network, and small industrial loads are served from the primary distribution network.
The industrial loads are composite loads and induction motors from a high proportion of these loads. These composite loads are functions of voltage and frequency and form a major part of the system load. Commercial and residential loads consist largely of lighting, heating, and cooling. These loads are independent of frequency and consume negligibly small reactive power.